The internet has been around for a long time and it's everywhere. Whether you're uploading photos to Instagram, scrolling through posts on Facebook, sharing links on WhatsApp, or simply watching videos on YouTube. One of the key players in the world of the internet is IPv4, Internet Protocol version 4, and that's exactly what we'll talk about in this video.
IPv4 is a connectionless protocol. It is used for a packet switch network and it is based on the best effort delivery model. The best effort delivery model means it does not guarantee the delivery of packets. To make it more reliable, we pair up it with our TCP/IP protocol.
Addressing in IPv4 consists of addresses which are 32 bits long. This means that if you want to know how many addresses are possible, then just write 2 raised to 32 which equals to 4 billion addresses. That's a huge number. And to make it human readable, instead of writing 32 ones and zeros in a line, to make it more human readable, what we do is we use the dotted decimal notation, in which we just write decimal numbers in 4 boxes. And these range from 0 to 255. And each of them is called an octet. IP addresses are divided into various classes, and which class the IP address falls into is decided by the first octet.
Now I am going to show you how to remember classes of the IPv4. IPv4 address is written as 4 decimal octet. So we will concentrate on the first octet of the IPv4 because it decides the class of the IPv4 address. We are taking the first octet of the IPv4 address. Here first octet contained 8 bits, so we will get 2 raised to 8 is equal to 256 combination. So range will be 0 to 255. Imagine one circle which start from the 0 and ends at the 255. So we will divide this circle in the 2 parts. This will become class A.
As you've seen, we divided the entire space into 2 equal parts, and one entire part is called class A. This means that half of all the addresses in the world fall under class A.
Now we have half of the circle for class A, and we have the total 256 value. Hence 256 divided by 2, it's 128. So our class A is ranges from 0 to 127. Now we will divide this half circle into further part. Then this will become class B. The starting address of the class B is 128. Now for ending address, we will divide this 128 divided by 2, that is 64. We will add the 64 in 127, that is 191. For remaining classes, we will divide this quarter circle in the 2 parts. This will become class C. The starting address of the class C is 192. For ending address, we will divide 64 by 2 is 32. By adding 32 in 191, we get 223. So range of the class C is 192 to 223. For class D and E, we divide this part in 2 halves. The first address of the class D is starting from 224. For ending address of the class D, we will divide this 32 by 2, that is 16. When we add 16 in 223, we will get 239. Hence class D is ranges from 224 to 239. For class E, the starting address will be 240 and ending address will be 255. So class E is ranges from 240 to 255.
Word on the street is that we are running out of IP addresses and that we may need this new IPv6 system to fulfill our IP address demands.
Problem is internet was created for computers only.
Then the smartphones came and they also require IP address to connect to the internet.
This means that we started running out of IP addresses much sooner than the dawn of the Internet of Things. So if we were running out of IP addresses, then how did we support all of these new devices? One way of doing this is NAT-ing, Network Address Translation. How this works is your router gets one IP address from your ISP. This might be something like this. Okay, it does not have to be this, but it could be something like this. And then the router itself connects all the devices using a private network of its own, in which all the devices get connected. They don't have the IP address from the ISP. Only the router has the IP address from the ISP. So what happens is, when your phone, say for example, wants to communicate with the internet, then it makes a request to the router at this address. The first address is occupied by the router. And the router on behalf of the phone will communicate with the internet, and whatever response is received, it will give it to the phone. This is called network address translation. A quick search on Google shows you all the private IP ranges. The range starting from 192.168.0.0 is a very common IP range. To check our own public and private IP addresses, we first download Fing from the Play Store. This app can tell you all about your own LAN connection. Now give it a couple of seconds and it'll show you all the IP addresses of all the devices connected to your LAN. Note that the first address goes to the router takes that address automatically. Now that you've seen the IP address of your router, just type it into Google Chrome or any other web browser that you like, and the configuration of your router opens up. The private IP address of your router is in the LAN section, and the public IP address of your router is in the WAN section.